Welcome to the Control Tower, everyone. I am absolutely thrilled to have you here today because, let's be totally honest, we're dealing with a completely high-stakes situation right now. If you are currently sitting the Cambridge AS and A-level Mathematics 9709 exams, or even building your foundation at the IGCSE level, you already know the intense pressure I'm talking about. Sitting in that exam hall feels like you are literally an air traffic controller trying to safely land heavy aircraft in the middle of a massive thunderstorm. Today, I'm going to be your elite tower director for this exact exam emergency simulation. We are looking at an explainer specifically designed to decode the probability and statistics one paper. We are going to completely demystify the normal distribution, standardization, and the normal approximation to the binomial distribution. And listen to me carefully. We aren't just going to sit here and blindly memorize formulas like robots. No way. We are going to look at exactly how Cambridge examiners think, how they actively grade your paper, and how you can systematically secure those elusive, top-tier marks under extreme time pressure. I want you to imagine two types of students out there on our radar grid today. First, we've got candidate Alex. Rooter Alex gets totally bogged down in the minor, low-yield details, basically circling in an infinite holding pattern and burning through all their precious exam time. Then we've got candidate Sam. Rooter Sam rushes the approach vector, clearing mathematical arguments for landing way too fast without even verifying structural safety regulations or basic assumptions. Our main objective today? We're going to make sure you aren't Alex and you aren't Sam. We're going to get you landing safely on that A-star runway every single time. Look closely at this quote on the screen. The difference between a B and an A-star in mathematics often comes down to how well you understand probability and statistics. 1. Normal distribution, standardization, normal approximation to binomial. Seriously, I need you to let that sink in for a second. We are diving into a true insider examiner masterclass today. Those top grades, they are absolutely not reserved for people who are just quote-unquote naturally good at math. That is a complete myth. Those top-tier marks belong entirely to the candidates who deeply understand the specific structural mechanics of what Cambridge examiners are actually looking for when they scan your response. It's all about knowing the flight manual inside and out. The difference between a B and an A-star is literally the difference between a really rough, bumpy emergency landing where you drop all your method marks and a flawless, full-mark touchdown. You have to know how to navigate the airspace when the questions get complicated. And today, I'm going to show you exactly what that flawless touchdown looks like, step by step, so you can confidently lock in those maximum points on test day without breaking a sweat. All right, let's dive right into this. Here is our structured roadmap for unlocking your A-star. We are covering Section 1, Essential Core Principles. Then, Section 2, the Procedural Framework. Section 3, Top Examiner Warnings. And finally, Section 4, Evaluative Problem Solving. Let's get moving. Starting off with Section 1, Essential Core Principles and Fundamental Mastery. The Cambridge Assessment Framework relies heavily on deep, evidence-based logic. Let's initialize the radar grid and see what this looks like. Okay, the normal distribution, along with standardization, forms your absolutely foundational conceptual framework. In our control tower simulation, this is your core navigation system. But I really want you to notice the key requirement written right here. Connected understanding that is transferable to unfamiliar contexts. That is a massive concept. What does it actually mean for you on exam day? It means you have to understand exactly how the mean, your mu, shifts your entire center left or right on the graph. You need to know how the variance, your sigma squared, dictates the exact spread of your bell curve. Is it tall and clustered, or is it flat and wide? And crucially, you need to understand exactly why standardizing to a z-score is completely necessary to actually calculate those probabilities. Standardization is basically translating the question into a universal language that the examiner's mark scheme can read and verify. This connected understanding is what allows you to adapt to literally any crazy scenario they decide to throw at you. Remember our candidate Alex from earlier? Alex is the type of operator who memorizes the textbook, maybe completes a few past papers, but completely freezes up when the exam presents a weird, real-world scenario, like measuring the weights of exotic fruits instead of standard factory machine parts. Cambridge examiners are intentionally going to throw those completely unfamiliar contexts at you to see if your radar breaks down under the pressure. So this fundamental mastery, it is absolutely non-negotiable. It's what keeps you locked onto the glide slope when the exam turbulence hits. You can't just know the what, you have to deeply, intimately understand the why and the how. So here is the stark reality of the situation. Examiners prioritize analytical depth over superficial breadth every single time. They are actively hunting for deep, structured reasoning. Believe me, sitting in that grading room, they can tell immediately if you are just blindly plugging random numbers into a calculator and hoping for the best. That's exactly what candidate Sam does. Sam rushes the approach, slaps down final numbers without properly showing the procedural work, and ends up crashing, losing all those precious method marks along the way. The examiners want to see the actual architecture of your thought process explicitly written out on the page. They want to see you take a complex, high-tariff probability scenario, break it down logically piece by piece, and solve it with absolute precision. That depth is what separates a decent student from an elite A-star Cambridge scholar. You need to prove to the control tower that you know exactly why you are taking every single mathematical step. It's not just about the final destination. It is entirely about proving you know how to fly the plane safely to get there. Let's move to and see how this builds in Section 2, the procedural framework for practical application. It's time to set up your approach vector. All right, we are actively routing the approach vector right now. Knowing the mathematical theory is only half the battle. Now we actually need the practical methodology to guarantee that you capture every single available mark under extreme ticking clock time pressure. This highly specific 5-step sequence is essentially your fuel to mark budget formula. It literally secures your method marks, which are your ultimate safety net. Let's break it down together. Step 1. Deconstruct the question actively. I don't mean just casually skim it, I mean tear it apart. Grab your pen, underline the key conditions, circle the variables. Step 2. Extract relevant data. You need to explicitly isolate your mu and your sigma squared right away and write them down clearly at the top of your workspace. Step 3. Select your analytical framework. This is where you make a critical routing decision. Are you standardizing here, or do you need to use a normal approximation to the binomial distribution? You have to make that choice deliberately based on the parameters you just extracted. Step 4. Execute with crystal clear mathematical notation. This is absolutely massive. And Step 5. Present with correct terminology. Following this exact, rigorous sequence mathematically guarantees you capture those crucial method marks, even if you make a silly, minor arithmetic slip on your calculator later on. If you skip these steps, you are basically flying blind in the fog. When candidates like Sam skip Step 4 and use messy, illegible notation, the examiners simply cannot follow the flight path, and the marks are instantly gone. You have to lay down the structural framework every single time. Shifting gears now to Section 3, top examiner warnings and direct alerts. Things are about to get very urgent on the radar. Tower transmission check. Okay, before we clear this response for touchdown, I need to make sure your transponder is fully updated. Go ahead and subscribe to Ace the Exams. That's at Ace the Exams right now, and turn on all notifications so you don't miss any of these critical exam masterclasses. All right, transmission check complete. Let's get right back to the radar screen. So the crucial point I need to make is that there are exactly 3 massive mistakes that consistently trap students on exam day. Think of these as amber warning lights violently flashing on your dashboard. It genuinely does not matter how well you know the underlying math if you fall headfirst into one of these specific pitfalls. These are classified grading secrets straight from the principal examiner reports. This is exactly where thousands of candidates throw away their A-star grades year after year. Let's break down exactly what these 3 traps are so you are fully armed and ready to avoid them when the clock is ticking down and the pressure is on. Think of these points on the screen as massive debris on the runway that will absolutely wreck your final score. Trap number 1, using the wrong approach for the wrong context. This incredibly common error usually looks like totally forgetting the absolute crucial continuity correction when you're applying a normal approximation to the binomial. If you miss that plus or minus 0.5, your entire calculation skews off the runway and you lose your accuracy marks. Trap number 2, forgetting to check your format and presentation. Remember, practical application in Cambridge exams requires professional mathematical skills. If your standardization formula looks like a jumbled, disorganized mess, you drop points. Trap number 3, answers are not specific to the context given. Listen, a naked decimal number just floating randomly at the bottom of the page is absolutely not enough. Does that 0.85 represent crop yields? Does it represent faulty factory machine parts? You have to tie your final mathematical answer back to the actual reality of the question asked. And here is an urgent flashing red examiner alert for you. Consistently confusing key terminology. You must define your terms clearly. If you use vague terminology, it immediately signals a vague understanding to the examiner, and they will severely penalize you. Clear terminology is your direct radio communication with the grader. Keep it crisp, keep it highly accurate. We are now transitioning into our final critical skill, Section 4, evaluative problem solving and critical analysis. Let's bring it in for a landing.
Now, what is really interesting about this slide is the stark contrast it paints between a standard candidate and a true top-scoring one. Consider this our live interactive runway workshop for a second. Look closely at the left side. The standard candidate, let's call them Router Alex again, really struggles to evaluate the quality of the given evidence. They completely miss the data limitations, and they just mindlessly compute the numbers without thinking. They hit an unexpected structural block in a multi-part question, and they just panic and freeze. But look over at the right side, the top-scoring candidate. This elite candidate actively questions the assumptions. They consider alternative perspectives, and most importantly, they systematically justify their mathematical decisions with solid evidence. For example, when they decide to use a normal approximation, they don't just blindly do it. They explicitly write out and justify exactly why the conditions n times p is greater than 5 and n times q is greater than 5 are actually met in this specific context. That right there is what evaluative thinking looks like. It's like deploying a peel formatting template, point, evidence, explanation, link, to guide your mathematical sentence right back onto the safe glide slope. They aren't just solving, they are proving their right to use the method. That's how you definitively prove you are an elite operator to the examiner.
To truly achieve that top-tier A-star status and log a successful full-mark landing sequence, you absolutely must employ this specific evaluative loop on every major question. Step 1. Identify the given information. We talked about this. Extract the data. Step 2. Break the problem down into highly logical, manageable steps. Step 3. Solve systematically without rushing the math. And then, this is the absolute crucial part that almost everyone completely misses in the heat of the moment. Step 4. Check for reasonableness. Look closely at your final probability. Does a 99% probability actually make logical sense in the reality of this specific scenario? If you are calculating the probability of a randomly chosen person being over 8 feet tall and you get 0.9, your math is horribly wrong. You need to have that built-in reality check to catch your own errors before the examiner does. Finally, step 5, make justified recommendations or conclusions based on your findings, tying it all back perfectly to the original context. This ultimate deconstruct, solve, and evaluate loop demonstrates absolute total mastery of the syllabus. It takes your entire response and elevates it from just average right to exceptional. I really want to leave you with this final, highly provocative thought as we officially close out today's simulation. Are your exam answers systematically justified with solid evidence, or are you just sort of hoping for the right number to magically appear on your calculator screen? Honestly, the difference between those two exact approaches is literally the difference between getting stuck at a B and achieving that A-star. You have the tools now. Use the fuel-to-mark budget formula, take the procedural framework we discussed today, avoid those massive examiner traps on the runway, and apply deep evaluative thinking to every single past paper you practice from here on out. Don't be an Alex, and please don't be a Sam. Step up and be the elite tower director of your own exam. Thank you so much for joining me for this explainer. Before you go, make sure you subscribe to Ace the Exams. That's at Ace the Exams. Enable that notification bell and leave a comment down below sharing exactly which Cambridge paper gives you the most anxiety. Keep studying smart, keep your approaches crystal clear, and I will absolutely see you next time.